Let us discuss Tower of Hanoi. Tower of Hanoi is a mathematical puzzle where we have 3 towers and NDs. So the objective of this game or this puzzle is to move the entire stack to another red. We have here the image of Tower of Hanoi. We have 3 towers. We have 1, 2, 3. You can name it as source tower, and this one is the auxiliary tower, and this one is the destination tower, or you can name it as A tower, B, C, or XYZ. Then in this tower, in the source tower, we have the stacks of these. We have the largest disk is on the bottom and the smallest disk is on top. And the objective of this game is to move all these to our destination tower. So this game was invented by the French mathematician Edward Lucas in 1883. Okay, to win the game, we have to follow simple rules. First, only one disk can be moved at a time. Second, each move consists of taking the upper disk from one of the stacks and placing it on top of another stack or on an empty red. Then, no disk may be placed on top of a smaller disk. So, let us now try to play this game using different numbers of stack or disks in a tower. Okay, so here in our case 1, we have 1 disk in a tower. So this our objective is to move to our destination tower. So we make a 1 move, and then this is now the result. So we just have a 1 move. Then how about in this scenario, we have 2 disks in a tower. First, the small disk, we need to move this one to our auxiliary tower. That is 1 move. Then this is now the current position of the disk. Our next move is to move the largest disk to the destination tower. And we have now 2 moves. Then again, our next, this is now the current location of the disk. Next, our goal is to move this one to our destination tower to complete the puzzle. So this is now the result, and we make a 1, 2, and 3 moves. So in a Tower of Hanoi, we have 3 moves to solve the puzzle. Next, let's move to play this game using 3 disks in a tower. So as we can see, we already know how to move these 2 disks to our destination tower. In this case, we will first use the strategy that we use here in the previous game that we play using 2 disks in a tower. So we will use this strategy in T2 to move this 2 disks to our auxiliary tower. Then our next goal is to move this one, the largest disk, to our destination tower. That is 1 move. Then next, these 2 disks, let's move this to our destination tower. Again, we will use the strategy that we use in T2. So we have now, this is now the result. We solve the puzzle using 3 disks. So we have used the strategy in T2 2 times. Then we have here 1 move in this case. So 3 times 2, we have 6 plus 1. So we get 7 moves to solve this puzzle. Okay, next, let's solve this one using 40s. Okay, we already know how to solve this one. These 3Ds, you already know how to move this to our tower B. So we will use the strategy that we use in T3. Then our next step is to move the largest disk to our destination tower. Then after that, we will use again the strategy in T3 to move these 3 disks to our destination tower and to solve this puzzle. Then we got this. So we use the strategy in T3 two times, plus we have here 1 move. So in total we have 15 moves here to solve this puzzle. So I will show you how to play using 3Ds and 4Ds. So now let's try to play this using 3Ds, and we have 7 moves only here. The minimum is 7 moves, so let's play. 3, 4, 5, 6, 7. Done. Okay, let's try to play having 40s in a tower. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Done. So at this time we can easily figure out our recursive formula. So T of n is equal to 2 times the previous step, which is T n minus 1, then we add 1. Okay. Here is now the pseudocode. So let us now analyze our recursive formula. So here we have T of n is equal to 2Tn minus 1 plus 1. Let's make this as our equation 1. Then let's solve this by using back substitution method. So T of n minus 1 is equal to 2Tn minus 2 plus 1. Let's make this as our equation 2. Then Tn minus 2 is equal to 2Tn minus 3 plus 1. This will be our equation 3. Then let us put the value of Tn minus 2 in equation 2 in this equation with the help of equation 3. So we have Tn minus 1 is equal to 2Tn minus 2 plus 1. So substitute the value of Tn minus 2. So we have now 2Tn minus 3 plus 1 plus 1. Let's make this as our equation 4. Then let's put the value of Tn minus 1 in equation 1 with the help of equation 4. So we have here 2 times 2T of n minus 3 plus 1 plus 1 plus 1. Then the sum of these, we have 2 cubed T n minus 3 plus 2 squared plus 2 raised to 1 plus 1. So if we generalize this equation, we have T of n is equal to 2 raised to k of T times n minus k plus 2 raised to k minus 1. So let us assume that k is equal to n. So substitute k with n. We have 2 raised to n t of n minus n plus 2n minus 1. So we have n minus n is 0, so we have here 2 raised to n times 0 is 0 plus 2 raised to n minus 1. So we've got here the big O of 2 of n minus 1, or we can say that the time complexity of this formula is the big O of 2 raised to n. Okay, so this one is the example in finding out the number of moves in solving the Tower of Hanoi with certain number of Ds in a tower. So for example, we have 3 Ds in a tower. So to know how many moves we need to solve the tower, so substitute the value of this here in n. 2 raised to n minus 1. So 2 raised to 3 minus 1, we have 8 minus 1 is equal to 7. So here in the table, we have here the number of these and the moves required to solve the puzzle. That's all.